This is demonstration video for SHIM latency measurement and insertion flow. This slide shows the flow. We assume a SHIM XML file has already created for block diagram of the target hardware. If not, create it using the SHIM 2.0 editor available on GitHub. In this flow, first, insert macros into the measurement programs, cross-compile them, and run the compiled files on the target hardware. Then, estimate latency value for each LLVMIR instruction, and finally, insert estimated latency values into the SHIM XML file. First, insert the macro into the measurement program. Place the directory containing the measurement program in Insert Macro in Measure. Go to that directory and run run.sh to insert the macro. On the left-hand side is before inserting macro. The right-hand side is after. You can see the added code in the red box. Cross-compile the code inserted macro and run it on the target hardware. The execution results will be output as a CSV file. The pink speech bubble is an example of the output results. The next step is to import the CSV files into exclude values, XLSM. Then place them in the same directory and run the macro reading CSV. Then run the macro run median macro to exclude the outliers. Set the allowable range for both cache access and refill. In this case, I set it to 0.2. Enter the information obtained from these into Calc. XLSM. Move to the regression sheet of Calc. XLSM and run the regression analysis. If values appear in the yellow column, you are ready to go. We will run the regression analysis using the solver function. Please refer to GitHub for constraints and objective cells. The estimated latency will appear in the green row. Finally, we will insert this latency into SHIM. To insert it, we will convert it to a CSV file. Again, run the macro output CSV and save the new file generated as input.csv. The location is in latency, trans, inst. Run transcsv.py in trans to generate output.csv for insertion into SHIM. Finally, run the amalthea tools.jar to insert it into the SHIM.